We're here. I'm Smash-O-Mash. You've reached the Smash News Network, least busted name in news, and this is the Daily Space Weather Show. These are just the past couple of hours of the GO 16 SUVI, and you can see some massive features hanging off the edge of the solar disk over there. Those are solar plasma filaments known as prominences. The same feature as the plasma filament, just hanging off the edge of the disk, as you can see. We've got some new sunspots that rose. We've got a bunch that are setting at a dipping sunspot number. We'll cover it and lots more today. We did have one significant flare. It was an M+ class event around 7:40 Universal Time this morning. There it is from SDO. Here are the past 24 hours from the same instrument, the SDO AIA, but 171 angstroms this time instead of 94. Here's a little closer view for you. Spectacular imagery there from Solar Dynamics Observatory. And let's just take a moment to thank all of our viewers, especially those who've already subscribed to the channel. If you haven't subscribed yet, congratulations on realizing it exists. Make sure you press the like button, press share, tell your friends and foes on social media that the channel exists. It's only the world's most comprehensive daily space weather content and most detailed solar imagery. So yeah, thanks to everybody who's tuned in. Cheers. Press all the things. We need your assistance to get the videos onto people's screens. The quote of today is from Friedrich Nietzsche: the man of knowledge must be able not only to love his enemies, but also to hate his friends. A little bit of levity for you there. And let's break down some space weather stats. The radio flux is at 164. So the 10.7 centimeter radio flux is a super important measure of solar activity, as it is directly proportional to sunspot number. You got a high sunspot number, you got a high radio flux, and vice versa. So there it is over the past year. And yeah, a little dip in the radio flux and the sunspot number today. It was hovering around 200. Now it's dropped considerably, and we'll see it continue to drop, although we do expect some more new sunspots to rise shortly in that southeast. We'll get to it. So NOAA is forecasting a mild geomagnetic storm tonight, so that's pretty sweet. July 3rd into July 4th, perhaps we'll have some mid-latitude auroras, fingers crossed for that, because of coronal mass ejection influences. So here's their forecast model. That is NOAA's Enlil spiral. So the possibility of some aurora tonight, always a good thing for the channel and for all of you aurora chasers. Here's ESA's forecast, and it's a little bit different, but there it is. That's European Space Agency's Enlil spiral. And they're not really expecting the same thing at all, but hey, the graphics speak for themselves. That's why we show them. So it is calm in the Earth geospace right now. No need to really show those geospace movies. KP2 is the current situation as far as global geomagnetism. Solar wind is pretty nominal here. ACE is showing about 3.5 protons per cubic centimeter at 400 kilometers per second. Very average. And Discover is showing a little bit higher density there at about 7 protons per cubic centimeter, but still only 400 kilometers per second. So pretty uneventful. GOES magnetometers remained smooth. No CME impact occurred. So there's that. And yeah, Earth is about to snap into a South Pole-oriented magnetic sector. There is our heliosphere. Here's what's going on. Here's our line of sight field plot. And things are frankly pretty mild right now. Here's our line of sight coronal hole plot. And we like to preface our showing coronal holes from SDO with this Gong 2 data, part of the National Solar Observatory. There's the last image. And we've got mostly South Pole-oriented coronal holes at the moment. So there's what's going on the past 24 hours at 30 frames per second and 211 angstroms from SDO. We've got some pretty well-defined coronal holes here rotating in on both sides of the solar equator. Let's move to sunspots. Sunspots. The sunspot number is now around 182. I'll say 182 is a sunspot number. Likelihood of large flares not that high. The best possibility would be sunspot 3729. It's got the most magnetic shear. It's got the most complex magnetic fields there, as you can see on the SDO magnetogram right in there. So let's take a look at the SDO magnetogram animated. There you have it. And the visible groups here don't look like they've evolved very much for the past 24 hours. We'll switch to the continuum and zoom in one step. So that's what approximately 180 sunspots look like. And again, only one M-class event for the past 24 hours. As far as energetic particles and solar flares go, only some minor spikes there, bringing us just barely up off the baseline for the greater than or equal to 10 mega electron volt goes 18 proton flux. Just a minor little uptick there, but the chance for more is certainly there. So don't be surprised to see a solar energetic particle event. And here's that largest flare again. That was around 7:40 universal time this morning. Peak flux was M1.49. And here's SDO 131 angstroms. You'll see that flare right by the corner of my overlay. And since that is our T mass, we'll zoom way in. So that is T-mass, the most active sunspot, and will also include 94 angstroms. Hopefully you've enjoyed that. We'll move on to do a solar system forecast. So here are things today as we approach new moon. That's where things will be in 1 week on July 9th. My, how time flies. And here's a star chart. This is what's going on over at our location, Lehigh Valley, Pennsylvania. If you like riding bikes, come join us for many world-class cyclists and thousands of riders and some of the best roads and indeed trails that you'll find the world over. Next is our astronomy photo of the day. It's a southern pinwheel galaxy known as M83. And what's cool about this image is it shows you the outskirts. You can see an extended halo there as that galaxy is thought to be disrupted by a neighboring galaxy. Now, it's pretty close by in terms of galactic locations. It's only, 12? So it's 40,000 light years across, and it is located only 12 million light years away. So not a super distant galaxy, and it's a little smaller than half the size of the Milky Way in terms of its diameter. Also sometimes referred to as the Thousand Rubies Galaxy, M83, the southern pinwheel. Great view of that, apod.nasa.gov. Next, moving on to CMEs. We got one out of the southwest, and that's the main coronal mass ejection feature of the past 24 hours. Here come our custom coronagraphs. So you're probably wondering if it's earthly directed, and the answer is we do not think so. So according to the available data that we have here, looks like it'll miss Earth well off to the south and west. Why not show it a little closer and add the 193 60-minute running difference imagery from SDO? That's pretty good. And note there are a lot of filaments there, so you might see a lot of dark absorption features, especially in the southern hemisphere, as well as prominences hanging off the edge of the disk. Those are plasma filaments, and they're known to turn into coronal mass ejections. So don't be surprised to see one of those. Let's move on to filaments next. There are filaments from Big Bear. And you can see, well, there is one pretty large one in the north, but mainly southern plasma filaments at the moment. And there you can see the prominences when we show the grayscale imagery. Some massive prominences, especially in the south and southeast. Let's show filaments from the perspective of SDO. That's pretty good. Yeah, not bad at all. All right, and what else do we need to show here? I think we're basically caught up. We'll show bonus features real quick. There are the past couple of hours, once again, from the GOES 16 SUVI. And again, I do expect to see more sunspots rise there in the southeast. I don't think those filaments are fully explained by the sunspots that are currently in view, but the ones we do see are at least beta class. We'll look at their fields in a minute. Bonus features include charging hazards, of which we don't have any. Electron flux here just moving around, warning levels there for the GOES 16, and just a little bit above electron flux warning levels for the GOES 18. NOAA's forecast there is for surprisingly high levels, despite them expecting a coronal mass ejection impact and a mild geomagnetic storm tonight. So I suspect if NOAA's forecast for incoming space weather is right, that electron flux forecast will be wrong. We'll show the layer where it's measured, which is the F layer. That's at about 300 kilometers of altitude. And there it is in megahertz. That diffuse gas occupying the bridge between Earth and space vibrates at a high frequency, especially under the noontime side of the planet. On the nighttime side, it vibrates less frequently. Or you could say it's cooling down, so to speak. The ionosphere, folks, the bridge between Earth and space. If that's all Greek to you, don't worry. Here's the anomalygram, and it's looking really average right now. So, I mean, look at how little red and blue is on there. Very average. Although the one thing to note that I feel like a broken record as I say it practically every day on the channel is that the South Atlantic anomaly has moved to about the 45-degree west longitude line. If you follow that negative 45 over there down at the bottom, you follow that up to the South American coastline, you'll be able to easily see that the South Atlantic anomaly is located there now. So, that's one of those things that you won't notice unless you look at the space weather data, especially if you understand and are familiar with the space weather data. That'll really help you to understand things, because any fool can know a thing. The question is, are you able to understand it? So let's look at our most complex sunspots, which are certainly these groups here. Very nice. Not too bad. Not too bad. So yeah, that's the southern one there is certainly beta gamma delta class. The northern one is beta gamma class. So that's something. And again, we do have two new large sunspots that just rose here in the east. So we'll take a brief look at those before we close things out. We'll cut back to filaments. So that's what's going on. Another beta class sunspot just rose. But solar activity has been pretty mild. Anyway, filaments remain a big story, so we'll close out on those. Thanks for tuning in. Congratulations on realizing the channel exists. I've been your host, Dan, a.k.a. Smash-O-Mash, and I am out of here. And until next time, may that solar wind be at your back.